In our previous lesson, we learned about all of our theorems about parallel lines cut by a transversal and all those angle pairs that are formed and the relationship between those angles. So today we're going to look at the opposite of that. We're going to prove that lines are parallel using those angles. So these are all converses. If we need to prove that lines are parallel, we're going to have to use the converse of these theorem. So this is the corresponding angles postulate converse, which says if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So just remember that the corresponding angles postulate said if two lines are parallel, then corresponding angles are congruent. This just flips it around. Our next one is the alternate interior angles converse, which says if alternate interior angles are congruent, then the two lines are parallel. Consecutive interior angles converse says if consecutive interior angles are supplementary, then the lines are parallel. And the last one is the alternate exterior angles converse, which says that if the alternate exterior angles are congruent, then the lines are parallel. So these are methods that we can use to prove that lines are parallel if we are given some congruent angles. So let's look at this algebraically. So starting off, it says find x so that m is parallel to n. So these two lines need to be parallel. So we have a measure here of 3x minus 5 degrees and a measure here of 2x plus 1. So if we look at these two angles, we need to figure out what kind of relationship they have. So these are alternate interior angles. So they are inside the parallel lines and they are on opposite sides of the transversal. So alternate interior angles converse is what we need to use. And that says that if our alternate interior angles are congruent, then the lines are parallel. So we need to have congruent angles. That means that their measures will be equal. So I'm going to set these two things equal to each other. 3x minus 5 equals 2x plus 1. And then I need to solve this equation. So I like to take care of my variables first, and I like to take care of the smaller one and move it. So 2x is the smaller coefficient. I'm going to subtract 2x from both sides. And when I do that, 3x minus 2x is 1x. And then my constants just stay where they were. This is positive 1. All right, so now my constant that's over here with my variable, I want to move it. Plus 5 on each side. Addition property of equality. So x is 6. So the value of x that will make these congruent alternate interior angles is 6. So we can test it to make sure that it works. If I plug it in, this will be 2 times 6, which is 12. 12 plus 1 is 13. So hopefully this one will come out to 13 as well. 3 times 6 is 18. 18 minus 5 is 13. So these would both be 13-degree angles. And since their measures are the same, that would make those lines parallel. So alternate interior angles congruent, the lines are parallel. So that's what this looks like if we are doing it algebraically. So now we have this figure and we want to figure out if any of these lines are parallel. So we're going to use different theorems to figure it out. So the first question is J parallel to K? So if I'm looking at J and K, I'm looking at these two lines for right now. So I want to find angles that are on those two lines. So the two angles that I see on those lines, I notice that this angle is 95 and this angle is 105. So if I look at the relationship between these two, those are corresponding angles. They're in the same spot on different lines. So since 95 and 105, those are not the same angle, and corresponding angles converse says that if corresponding angles are congruent, then the lines are parallel. So 95 is not equal to 105. So no. And the reason is because of the corresponding angle postulate. So since we don't have congruent corresponding angles, we can't say that the lines are parallel. So the next thing we're going to look for is L and M. So let's get rid of what we have here so that we can look at L and M. So L and M are the horizontal-ish lines. So we have L and M, and I want to know if they're parallel. So I want to find angles that are on those. So looking at angles that are on those, between the two lines, we have 65 and 48 on angle L, or on line L, and then we have a 65 on line M. So I don't really have a connection between this 48 and the 65, but I do have a connection between the two 65s. So if I want to figure out what kind of angle pair this is, they are inside the line, so it's interior, and they're on opposite sides of the transversal, so that's alternate interior angles. So 65 is equal to 65, and that is going to be yes, because of the alternate interior angle converse. So whenever I said postulate up here, I should have said converse. So remember, it's always the converse if you're trying to prove that lines are parallel. So since these two alternate interior angles are congruent, that means that the lines are parallel. So next we're going to look at a proof. So here we are given that M is perpendicular to P and M is perpendicular to Q. And we want to write a proof. So since these are both saying perpendicular, I can introduce those two together. So let's do both the givens at one time. M is perpendicular to P and M is perpendicular to Q. Those are my givens. So since they are perpendicular, I can use the definition of perpendicular, which says that if two lines are perpendicular, then they meet at a right angle. So angle 1 and angle 2 are right angles. And that's by the definition of perpendicular. So since they are both right angles, I know that all right angles are congruent because they all have a measure of 90 degrees. So the right angle congruence theorem is going to let me say that angle 1 is congruent to angle 2. All right, and so angle 1 is congruent to angle 2. Now we have two angles that are congruent. Now let's look at their relationship. So for these two angles, those two angles are congruent, and they're both inside these two lines. We're trying to prove that P is parallel to Q. It's inside the lines on opposite sides of the transversal. So that is alternate interior angles. So we can say that P is parallel to Q by the alternate interior angle converse. So we use the converses to help us prove that two lines are parallel. So the theorems or the postulates just tell us about the angles. The converse actually lets us say that they are parallel going the other way.